This is Lesson 8, Polynomials. So what is the definition of a polynomial in X? A polynomial in X is an algebraic expression of the form shown. A to the sub n x to the n plus a to the sub n minus 1 x to the n minus 1 all the way to plus a to the 0. A to the sub n, a to the sub n minus 1, a to the sub n minus 2, a to the 1, a to the 0 are all real numbers, okay? A to the sub n is not equal to 0, and n is a non-negative integer, okay? Now, the polynomial is of degree n, okay? And a sub n is the leading coefficient. And a sub 0 is the constant term. Okay? So this appears to be a very complex expression, but it covers all possibilities, and we'll look at some actual examples of polynomials. So here's an actual example of a polynomial. 6x to the fourth minus 3x to the third plus 2x minus 5. Now the degree of this polynomial is 4. The leading coefficient is 6. And the constant term is minus 5. But notice there's no x squared term. Now, that's fine, because that just means the coefficient for the x squared term is 0. So you don't have to have every single exponent. You can be missing some, which implies that coefficient is 0. But this is an actual example of a polynomial in X. Now, what if we want to add or subtract polynomials? Whenever you do adding or subtracting of polynomials, basically what you're doing is combining like terms. So we're talking about terms that have the same exponent raised to the same power. Let's look at some examples. So here's an example of adding two polynomials. I've got one polynomial minus 9x to the third plus 7x squared minus 5x plus 3, and I'm adding it to a second polynomial, 13x to the third plus 2x squared minus 8x minus 6. Now, remember what I said, we basically combine like terms. So notice, let's look at this first term here. We've got an x to the third term, okay? And so there's our x to the third term. Now, do we have any other x to the third terms? Yes, right here. So we can combine those two. Now, let's look for the next. Next, we have an x squared term right here. Okay, well we have another x squared term right here, so we can combine those terms. Now let's look next. Next we've got an x term, minus 5x. We've got another x term over here, minus 8x. So we can combine those as like terms. And then lastly, the constant term, in this case, is plus 3. And the constant term over here, which is the like term, is minus 6. So what we're going to do is combine the like terms. Now when we combine our like terms, we end up with the following. 4x to the third plus 9x squared minus 13x minus 3. And if you look back what we started with minus 9x to the third plus 13x to the third, which ends up being the 4x to the third. And similarly with the other like terms. So adding and subtracting is simply the combining of like terms. Now let's look at a subtraction problem. Okay, again we're going to look for like terms. So we've got an x to the third here, an x to the third there. Then we've got an x squared here, and an x squared here. Then we've got an x term here, and an x term here. And lastly, we've got a constant term, minus 6 here. and a constant term plus 9 here. Now, the only thing you have to remember here is that we're subtracting. So we have to change all the signs in the right-hand polynomial. So this polynomial over here, all the signs have to change, and then we simply combine or add them like we did previously. Well, if we do that, the result is as follows. And now we have 5x to the third minus 2x squared plus 12x minus 15 by doing the subtraction of polynomials. Now what about multiplying polynomials? How do we go about doing that? Let's start by looking at some examples. So, our first example, 3x to the fourth times a three-term polynomial, 2x to the third minus 7x plus 3. Basically, what we're going to do here is distribute the 3x to the fourth. So we're going to multiply the 3x to the fourth times the 2x to the third. Then we're going to multiply the 3x to the fourth times the minus 7x. And then we're going to multiply the 3x to the fourth times 3. And when we do all that, the result is the following. 6x to the seventh minus 21x to the fifth plus 9x to the fourth. Now, whenever you're doing this, remember your laws of exponents. When you're multiplying, for example, the first term, 3x to the fourth times 2x to the third, what do we do with the exponents? We add them, okay? So 3 times 2 is 6. Then we add the exponents, which gives us 6x to the seventh. So now let's look at another example. So what if I had a binomial, 2x plus 3, multiplied times a trinomial, x squared plus 4x plus 5? So how do we distribute the 2x plus 3? Well, it's actually pretty simple, because we're going to take the 2x and we're going to distribute that first to the x squared, then to the 4x, and then lastly to the 5. Then we're going to take the 3 and multiply it or distribute it to the x squared, and then to the 4x, and then to the 5. And when we're finished, we're simply going to combine the like terms and come up with our final answer. So our final result, after distributing each of the numbers in the binomial and combining like terms, is 2x to the third plus 11x squared plus 22x plus 15. So now let's look at one last example of multiplying polynomials, and this is sort of a special case. So now we are multiplying two binomials. Now, one way we can do this is we can follow the same procedure we did up above when we had a binomial multiplied by a trinomial. But the other way is to think of this as the multiplication of two binomials by using the FOIL method, F-O-I-L, okay? So if we are FOILing, we multiply, the F stands for first term, so we're going to multiply the 3x times the 4x. O, outside terms, so we're going to multiply the 3x times the 5. I, the inside term, so we're going to multiply the 2 times the 4x. And then L, for the last terms, we're going to multiply the 2 times the 5. Again, after we do all this, we're going to combine our like terms and come up with our final answer. And our final result comes out being simply 12x squared plus 23x plus 10. So basically, these are three cases of how do we go about multiplying polynomials. And these can pretty much be extended to all situations where you're multiplying polynomials. Now, there are a few special products which are useful to know and memorize, and these we're going to discuss now. The first is whenever we have something like this, two binomials, but the only difference is the sign. So we got a plus b times a minus b. If we multiply those two together, the middle terms cancel each other, and we simply end up with a squared minus b squared. The second of these is a plus b to the third. So this would be the case where we have a plus b times a plus b times a plus b. And the result is a to the third plus 3a squared b plus 3ab squared plus b to the third. Similarly, if we had a minus b to the third, which would basically be a minus b times a minus b times a minus b, the result is a to the third minus 3a squared b plus 3ab squared minus b to the third. Now, one last thing is that we can have a polynomial in more than one variable. We've only talked about polynomials with one variable, x. We could have polynomials with two variables, x and y. That is possible as well. So just be aware of that, because we could have a situation where we might have 3x plus 2y times x minus y, and that would end up with a polynomial in two variables. So that is also possible. All right, now I'd like you to proceed to the worksheet. Try the worksheet, compare your answers with the answer sheet, and then do the mastery quiz.